Osmosis iti siya diffusion. Diffusion iti masak na ya. What is diffusion? Net movement of any substance from a region of higher concentration to lower concentration. Vale. Diffusion thi siam na dina diagram kon gel jol dia. Suppose you have this kind of setup. Alaya here, this is called membrane. Membrane. Okay. Solution. Okay. Umdan chubang yai khatna. Okay. Concentration of 1, meaning this side. Yalam khas sangzo. Concentration of 1 is greater than concentration of C2. That's this side. Concentration of solution 1. So this is 1. Solution 2. Solution ki banglo to koi khomi. So yalam kha concentration of solution 1 lam tam sangzo ijakina. So in between this membrane allow movement of substance. Movement of substance. So C1 akipan solute pai the. C2 lam. Aile C2 lam solvent le pai the tuiji ho. Okay. Solvent can come from C2 to C1. Solute can go from C1 to C2. Right. Ekha diffusion hai. Akikala bangma dalna thupium lo. Anybody can come from each side. Okay. And osmosis. Ki bang diffusion to osmosis ki bang lo hai. Okay. Osmosis is same setup, experimental setup. We will not keep in laitaka membrane naran koilodi. We will keep semi-permeable membrane. Semi-permeable membrane. SPM. When chichu. Okay, this is concentration of C1 is greater than concentration of C2 to he. Okay, lele C1 akipana C2 lama solute by the dal de semi-permeable membrane. Solute, okay, transfer of solute is not allowed. Okay. But whereas from solution 2 to solution 1, solvent can go. Solvent to pai sakte. So SPM function bangale. Okay, it does not permit movement of solid particle but allow movement of solvent from lower concentration to higher concentration. Example of SPM, semi-permeable membrane, are animal membrane, cellophane, copper ferrocyanide. Copper ferrocyanide, same structure is this. FeCN6. Now, osmotic pressure. What is osmotic pressure? Osmotic pressure. This is represented by pi. Okay. So the net movement here lama C solution 2 ke but solution 1 solvent movement pen ke le we can control the net movement of solvent molecule from from solvent to solution, from solvent to solution can be stopped by applying some extra pressure okay, over the solution side. This pressure is called osmotic pressure. This pressure which stop the movement of solvent, is called osmotic pressure. Yeah, a formal definition. So thus, osmotic pressure is what? Osmotic pressure is defined as the pressure which stop the movement of solvent molecule from solvent to solution side through a semi-permeable membrane. A diagram here, okay, so now check derivation equation con page there. Solvent lama here. This is solution. SPM here. SPM. Okay. Yellow maha. Okay. Ithedi. Atmospheric pressure leoma. Atmospheric pressure. Nature omgi gema. Omsa ma. Yalan pante. Okay. Plus osmotic pressure. Pressure bang jayam extra ya apply sukdi. This is a piston. Piston item. Atmospheric pressure plus okay. Osmotic pressure ya apply. Yellow machu okay. It is 7 atmospheric pressure choma. Okay. So here solvent akipat solvent solution pipe hedite na dal to the right amount of extra pressure we have to apply here. That is your osmotic pressure. Okay. Setup kaya dane. Okay. Experimentally, osmotic pressure, which is pi, is directly proportional to molarity of the solution. Molarity molarity is number of moles of solute divided by volume of solution in liter. Okay. Also, osmotic pressure is directly proportional to temperature. This is in Kelvin. Okay. Experimentally, this is true. Okay. So that means pi is equal to osmotic pressure. Suppose M, capital M, MT. Pi is directly proportional to MT. remove this proportionality sign into equal to sign, you will get what? There's a constant called solution constant. R is coming. R empty. Right? What is R? Solution constant. What is R? What is it? Okay, so or okay, you're right, like MRT. Keep this in mind. This is MRT. Okay. What is T? Temperature in Kelvin. What is M? Molarity in. Okay, molarity of the solution. R is solution constant. Okay, Zi pen okay, M. What is molarity? Here. Number of moles of solute, small n. Volume of the solution. So in place of capital M, you can put N by V, right? So pi is equal to this one. Okay. So final equation for osmotic pressure is this. Okay, numerical tetam pium there and apply on them. Topic poimonon mama. Van Hoff factor. Van Hoff factor conjunction on there. This is given by this is represented by small I. So definition is this: I equal to total number of moles of solute after dissociation or association. Example on hipilang is divided by total number of moles of solute before dissociation or association. And only number of moles after dissociation or association. This is before association or dissociation. Example penny. Now, sodium chloride. In aqueous, what happened? There will be 100% dissociation. 100% dissociation. Into what? Na plus ions. Aqueous is a tui lakaum, tui. Chlorine ion, aqueous. Yeah, tungla, how many moles? Neihsial, yeah, coefficient so there's 1 mole. Okay, so yalamala Na plus 1 coefficient is 1, so this also is 1 mole. Chloride ion also is 1 mole, right? Well, what is the Van Hoff factor? Okay. See, total number of moles of solute or whatever. Okay, after dissociation. After dissociation, what? How much moles is here? Khatni 1 plus 1. Before dissociation, this is 1 mole. So 2 by 1, which is 2. So Van Hoff factor for Neihsial. Okay, dissociation is 2. Example done. MgCl2, manganese dioxide. In aqueous, Mg2 plus 2Cl minus. How much mole? 1 mole. 1 mole. Over here is 3 mole of chloride. Okay. Aqueous. This is also aqueous. Van Hoff factor calculator. How much? I equal to number of moles after dissociation. This is 1 plus 2. Number of moles before dissociation 1. So 3 by 1. This is 3. Van Hoff factor for MgCl. Dissociation is 3. Khati line. Let's see dissociation of aluminum sulfate. Okay, 2Al3 plus plus how much? 3SO4, 2 minus. 1 mole here, okay, 2 mole over here, 3 mole over here. What is the I value, Van factor value? 2 plus 3 by 1, so 5 by 1, which is 5. Van factor for dissociation of Al2SO4 3 as 5. Okay, Van factors are done here, done. Okay. Solubility. What is solubility? Okay. It is defined as amount of solute in gram dissolved in unit volume unit volume usually is 1 liter of a particular solvent to form a saturated solution, saturated chichu solute dissolved in all a limit tungta bang ma helle chele janno lodi okay solute. So to form a saturated solution at a given temperature and pressure. Temperature and pressure. Okay, pressure. This is solubility, right? What is the unit? Unit of solubility? Okay. Gram per liter. Okay, gram pen mole. Sometimes we use moles. So moles per liter. Okay. If this is solubility, solubility depends on which factor? Factor on which solubility depends? Okay. Factors on which solubility depends. Nature of solvent and solute. Nature of solvent and solute. Nature of solvent and solute. Polar solute. Polar solute. I'll give you one example. Okay. Dissolve in polar solvent. Polar solute dissolve in polar solvent. Polar solute take alcohol, let's suppose. Example. I'll just give you one example. Neihsial, this is very polar. It has plus and minus. Okay. It's highly dissolved in water. Polar solvent is okay. It's two as well. Polar water H plus O minus. Charge something very polar. Again, we call them very polar. Polar solute tekha, polar solvent and no taka. Okay, tui thei papa ma, tui example. Alangkha tabang non-polar solute. Non-polar solute. Non-polar solute is dissolved in non-polar solvent. It's dissolved non-polar solvent. CCl4, carbon tetrachloride, is highly dissolved in benzene. Benzene to non-polar, charge something low, but non-polar solute here charge something. So non-polar solute dissolved in non-polar solvent. Polar solute dissolved in polar solvent. That is the meaning. Okay. Point number 2, temperature. Okay. For endothermic reactions, endothermic reactions with isa ya bang. Heat is absorbed. Endothermic heat is absorbed to start the reactions. Heat is absorbed. So for endothermic reactions, if you increase the temperature, solubility also increases. Yes. Exothermic lah. For exothermic, so heat is evolved. Temperature heat is evolved. Okay. Heat is evolved. Heat is given out. Yet the temperature increase in the solubility. Okay. For exothermic, solubility decrease with increase in temperature. Thumna pressure. The pressure, effect of pressure on solubility. Say for solid solute, right? Solid solute or liquid solute. Okay, there's lots of pressure already compressed. It is gas already compressed. But for gases too, okay, atoms are very free. Okay, they have haphazard arrangement of atoms. For gases, you have chances of compression. There's room for application of pressure. Solid to liquid tape, pressure applied. For gases, things is different. You can apply gases. Okay, so effect of pressure, discussion Henry's law. Henry's law is very important in solution topic. Okay, so solubility of a gas in a liquid is directly proportional to the what? Partial pressure of that gas, directly proportional to the partial pressure of that gas above liquid surface. Henry's law basically. This is called Henry's law. Henry's law. So again, solubility of gas in a liquid is directly proportional to partial pressure of gas. This is P, okay. And solubility of a gas is it's a mole fractions. Mole fraction of that gas in a liquid is directly proportional to mole fraction is given by this chi, right? It's a partial pressure of this. So finally what happened? Gas. P gas P gas is directly proportional to mole fraction of the gas in the liquid. Okay. So P gas is equal to there'll be some constant coming. This is called Henry's constant. Okay. Mole fraction of the gas. This is the famous Henry's law. Right? Partial pressure of the gas is equal to Kh equal to mole fraction of the gas. This is now the topic poimo thing. If can covers okay, poimo tampi con cover pia. Eta ning con zoria ke pake. Ole. Yai Siamkhanthang. Aya. Chemistry chapter 2. Physical chemistry chapter 2. Solution nahi to ni topic de. Okay. And solution solute solvent ki gom khom ina bola ya solute kha it's the smaller amount atoms of it. So textbook and legend smaller part equal a smaller amount. Solvent pen it's a larger amount. Okay. Exactly na say 20% of ethanol solution. 20% of ethanol solution hichi bangchi na le when done tak chu 20 zala ka somni kha solute wai chu ethanol adangom lai teng somgyat teng kha tui is the water which is solvent. Okay. I kile 80% ethanol solution bangchi na chile 80 part kha okay, ethanol and adang teng kha water. So solution is what? Solute plus solvent. A detailed textbook on enun lan till new like definition of solution solvent. Poimo ma solution okay, vapor pressure ji kon gen chang de vapor pressure. Okay, by definition vapor pressure is what? Pressure caused by evaporation of liquid. What is vapor pressure? The formal definition them say get there. Here to gizoi to na a basic thumapi ite di tampioma tilhat kon gen masada. There's something called open system. Okay, thermodynamics are open system in legend. Suppose this is your yes, one has solution of it. These are molecules of atoms of solution. Yes, it's only the night pen. Okay, atung ki hong hile. Evaporate changwa. Okay, paiswag deal. Okay, lengthia open system hai jagi. Alangkha the closed system which banga. Closed system chu atung leki hu ni so situation ki bangya okay evaporate dio ya atung ki khoi changa pai sok ta thelo ki dio okay ki su non dio koi na pressure on create di so till ni kineta. Okay. Kwayamina vapor pressure he is referring to closed system. Open system of vapor pressure ki develop ngelo. Acha chu leng khia polam leng khia jen. Okay. Vapor tena pressure anoilama a pressure ni hi nandi chance nei no lo nei lo he. Ai le ho ye. Closed system vapor pressure on my le. Okay. Diagram non dia khalwe. Solution ita hai. Molecule has suppose we have only one type of say molecule like atoms yang and hila. Okay. Yeah, le atom ya atom ya. Okay. Ai le enule ya surface even a surface kaya atom omte kha they are called okay, surface molecule adang la anwai lama tatam omte Noilama igel lote natanina. Okay, they are called bulk molecule. Okay. Igel suklaile. Okay. So, okay, atunga surface kenga, okay, no lamteka surface molecule and the rest is bulk molecule. I lay, okay, evaporation ichita okay, which molecule will evaporate first? I tell which molecule will evaporate. No, yeah, surface kenga molecule amte they will evaporate. Azia chini. Why is that only surface molecule evaporate? It's due to lesser force of attraction. Lesser force of attractions. Bang chitanin. Yanole. Yelama akisukag pi ekila suboy tudi ekila force. Yaw minchen. Side yeah, surface molecule amte ha uchilo wadang te endile every corner there's interactions with other molecule, no? Yes, okay, compare, yeah, surface molecule to yeah sungla bulk molecule ka compare diule. Yeah, surface molecule, they have what? Lesser force of attraction. Freedom nahi jo, why jaka? Nahi ta temperature na increase le surface molecule they evaporate faster. No, they will evaporate. And here no na, okay. This surface molecule they have more kinetic energy. More kinetic energy compared to other molecule. Okay. Kinetic energy how they are more free, movement hard, okay, they are more mobile, so they evaporate. Bangjaka surface molecule they evaporate. Aile hoye vapor pressure, okay, formal definition conpedia. What is a vapor pressure? The pressure of vapors above the liquid surfaces. Okay, is called vapor pressure. Vapor pressure is defined only for closed system, closed thermodynamic system. Very good. I lay vapor pressure banga definition ipekin tawa. Next is factor on which vapor pressure depends. Okay. Next is vapor pressure depends on which factors. Okay. Vapor pressure depends. Next topic study on, yeah. It depends upon the nature of a substance. It depends upon the nature of the substance. It's sagnadina tui to ethanol C2H5OH, ethanol to water compare ole. So question is, water and ethanol, who will have higher vapor pressure? And you learn, okay, from experiment, one water molecule. This is experimental observation here. One water molecule form 4 hydrogen bonds. It is a water molecule ka V shape even, no? The water molecule team hydrogen bonding again hydrogen bonding is that bond which hydrogen form with any electronegative atom. Electronegative atom te bang chlorine, oxygen, nitrogen. Suppose hydrogen bonding khatoma yele khatom the hydrogen to any electronegative atoms okay element cha tui water molecule ke suk to changwa hydrogen bond amagi kala libang ki form the pa mo. This is the situation with water. Ethanol. So experiment akipat ithe for one ethanol molecule. Okay, they forms what? One ethanol molecule to say they form one hydrogen bond. Just one. Ethanol molecule gelwale C2H5 oxygen hydrogen khatam the. OH H5C2. Hydrogen bond hydrogen to oxygen. Yes. So what did we observe? Ethanol molecule, one hydrogen bond is formed. One hydrogen bond is formed, but for this case of water, there are 4 at the same temperature and pressure, room temperature 25 degrees centigrade, Kelvin at 298 degree, atmosphere 1 atmosphere. At the same temperature, you compare this water and ethanol. Vapor pressure of ethanol is more than vapor pressure of water. Well, ethanol in hydrogen bond khatsone was a free zone. Why is it? That bonds break up. It's a very weak bond. Hydrogen bond is very weak. A bond so they are more mobile. They can evaporate easily. Whereas in case of water, hydrogen bond li takina ga khome chaga. Evaporation ka hard lows. Therefore, point number 1, nature of. It depends on what nature of the substance. Reactant lagte tuimo aikele ethanol zu vichika. Vapor pressure depends on nature of the substance. Point number 1. Why no nature of the substance? Question on paithe suppose you were given what ethanol, nina glycol, tumna glycerol. Question on paithe nature of the substance. Decide the value of vapor pressure. Ethanol is given. Suppose C2H5OH and all that. Glycol na Neihsial C2H2 ngalama OH on the C2H2 OH. glycerol CH2OH, CH2OH, CH2OH. Okay. Inolena. Yeah, hydrogen bond bangza ki form the dale ki form the ne. Hydrogen to oxygen ya om the. Yele hydrogen to electronegative atom yele om the. Okay. Why is that? Okay, so vapor pressure of glycerol is okay highest. Next is glycol, and the last is ethanol. So vapor pressure. Okay, the order of vapor pressure is like this. Bangzakin, nature of the substance. Khatka glycerol, a structure in the end. Bangzakin, okay, hydrogen bond tampen. They are not free. Okay, there are lots of attractions, okay, around them. Glycol, they are okay, lesser hydrogen bonding than glycerol. And lastly, ethanol. There is the least hydrogen bonding among them. Vapor pressure of glycerol is highest. Next is glycol, and then last is ethanol. Next, the solution. Okay, vapor pressure. To saya, sorry. So, substance. Hian bangza hiam in hian le. Okay. Khatna volatile chichu which can evaporate easily. Okay, it can evaporate. Khatpen non-volatile. Okay. Evaporate low, evaporate ming low. Okay, just not evaporate. Right, substance khachini in the vapor pressure to kisai division bolle. So khatha volatile substance nina non-volatile substance. The example one in Gilsugle. Okay, so yeah, evaporate ichichabang. Evaporate ichicha. The vapor pressure is not equal to 0. It will have some evaporations. It will have some value of vapor pressure. Lampang achubang. Vp vapor pressure will be 0 because it does not evaporate. Volatile example are water bang, okay, methanol bang, methanol, then again ethanol, CH5OH, okay. Benzene, C6H6, toluene, C6H5CH3, non-volatile lama example, urea, glucose, sucrose. Ito ka non-volatile example. Yahulim ko komina dina factor on which vapor pressure depends. Temperature, contribution of temperature is also very important. Temperature. It's a temperature. Evaporation hard di, yes. Evaporation hard le, vapor pressure increase. So graph draw le, yelama vapor pressure, y-axis, yelama temperature. So it will go, yes, temperature is increasing, vapor pressure increase. Factor on which vapor pressure depends. Yeah, then control sakte hain. Enole ano na poimo mama. Okay. Rouse law basic form to lehi. Yeah. Okay. A full form kun gelon kida VP vapor pressure. Okay. Of solution containing two volatile liquid. This is the basic of Rouse law. Yeah, basic na thei le Rouse law na no me. Okay. On dan chu okay reactants ni ladi white aniwa volatile meaning evaporate di aniwa. Diagram draw ni la. Okay. See in a vessel you take one pure liquid air. Pure liquid air. This is volatile. Pure liquid B. It also is volatile. And you are volatile. What it says? Two volatile liquid. And what? Molecule A as a pure A. Okay, till then to mix nailo hai. Molecule A ya oma surface aate ang evaporate deu as ya again hinta they evaporate. Pai hithelo onki ko so they exerted some pressure on the surface. Okay, that is our vapor pressure of A, P subscript A, PA. ये P और रही जगह नहीं है अतुंगा not कोई नहीं. Okay, P not A. P not A is what? Vapor pressure of pure liquid A. Yeah lah. Ele liquid chikhat. So say this is pure B. Evaporate the pressure. So the vapor pressure is P not B. Vapor pressure of pure liquid. Ethical react in a AB solution on form. A on B on to pure no. It's a mixture. It's a solutions. A mixtures of what? A and B. Yeah. A in the pressure nahi like yes. Abhi koni hai ye khab pressure on like A pressure due to A okay pure inology not koi inology you just call it PA. This is called partial pressure of A meaning mixtures are A pressure. Yeah, BL, P not B now, just PB. This is partial pressure of B. Okay, so what is P not A? Okay, comma P not B. This is a vapor pressure of pure A and B, respectively. PA to PB is a partial pressure. Till then, the mix pressure is called vapor pressure. A partial vapor pressure. Why? Yeah, Rouse law basic here. So, Rouse law define Rouse law. Formal definition is like this. In a solution, in a solution, this is solution AB. In a solution, at a given temperature and pressure, at a given temperature, the partial vapor pressure of each component. Components A and B is directly proportional to the mole fractions. Mole fractions ka dem che gen chang dia. Mole fraction of that component. In a solution at a given temperature, the partial vapor pressure of each component is directly proportional to the mole fraction of that component. What it means is, partial pressure of A is directly proportional to the mole fraction of A. This chai. Mole fraction, can revise piece all there. Say suppose you have two components A and B in a solution. Mole fraction of A, okay, it's number of moles of A divided by number of moles of A plus number of moles of B. Number of moles of solution, or chai B meaning mole fraction of B is number of moles of B divided by Na plus Nb. So partial vapor pressure of A is directly proportional to the mole fraction of that component, meaning A component. So Pa chai A. Wait, partial pressure of B component is directly proportional to each mole fractions. Chai B. Then again, so Pa directly proportional to chai A, P, okay, Pb directly proportional to chai B, directly proportional equal to sign Heckleuchin. There will be a constant term khatong paidi hoy. Experimental what they observe is that constant is P not A, vapor pressure of pure A, chai A. So P partial pressure of B is equal to that constant is P not B. This is experimental azon kya kohi hai. Okay, so Rao's law. Rao's law is nothing but ethical statement. Partial vapor pressure of each component is directly proportional to each mole fractions. So this is Rao's law. Partial pressure of the component A, partial pressure of component B. Now, what is the vapor total vapor pressure of the solution? Okay, so P total equal to partial pressure of diagram. What is P total? P total is partial pressure of A plus partial pressure of B. This is the P total. Total pressure, total vapor pressure. This is called Dalton's law. Dalton's law like it's total pressure in a total vapor pressure of the solution. It's Dalton. PA, what is PA? P naught A chai A plus P naught B chai B. This is P total. So this is Dalton law. This and this is Rao's law. Okay, now the Rao's law to Dalton law it is same na dingana numerical khat kon hi pizola. Tama ya numerical so textbook na enun lan mun ton ton na zong kho man. So now in the 3 moles of ethanol and 1 mole of methanol are mixed at a particular temperature. Okay. What is given is partial pressure of, not partial, vapor pressure of pure ethanol, E for ethanol, is 55 mm of mercury. Vapor pressure of pure methanol is 50 mm of mercury. Find P total pressure of, total vapor pressure of the solutions. Okay. And we'll answer mole fraction of ethanol masane. Number of moles of reaction ya gelzwale. So ethanol 3 moles plus 1 mole of methanol 1 mole. Right? It's giving the solutions. And mole fraction of ethanol. So number of ethanol. So a formula gel pole khape. Ne. So number of ethanol plus number of methanol. Moles of methanol. Number of moles of ethanol is how much? 3. 3 plus 1. So this is 3 by 4. Right? Yeah. Mole fraction of methanol is number of moles of methanol. Number of moles of ethanol plus number of moles of ethanol. Number of moles of methanol is 1. 3 1, so 1 by 4. Okay. Now, so according to Dalton's law, P total is equal to partial pressure of ethanol plus partial pressure of methanol. So P total is P naught ethanol chai ethanol, P naught methanol mole fraction of methanol, P naught E. Yeah, this one. 55. Okay. Mole fraction of ethanol 3 by 4. Then I calculate here. P naught methanol bangza 50. Mole fraction of ethanol bangza 1 by 4. We will cross multiply on land. Okay, LCM will be 4. 3 5 15. Okay, so 165 plus 50. Okay, so if 215 divided by 4, okay, equal to 53.7 same unit mm of mercury, right? Rouse law bang, okay, Dalton law bang, Dalton's law bang is a dan yai bang here. Okay, numerical term beyond the anazongan. Okay, and vapor pressure diagram. Next topic is VP diagram. Component A, which is volatile. Component of A vapor pressure is P naught A. plus component B. This also is volatile. P naught B. AB solution. Right? Whose vapor pressure is given by Dalton's law. It is a diagram again. Compression teacher mole fraction chila. Try. Yeah, pure A, pure component A koi di, pure component B. Mole fraction of pure A 1 koi masadiya. 1 ni koi masagle akhat pen, so akhat pen teacher mole fraction of B 0 hinga. Bang second. Okay. Both summation has to be equal to 1. Yeah, sige kon gen sig dia. Mole fraction of A is equal to plus mole fraction of B. What is mole fraction of A? Na plus divide Na bar plus Nb plus Nb Na plus Nb. LCM lawo Na plus Nb. Atung lang le Na plus Nb. Nb. Okay. Divide legend 1. Mala. Chai A plus chai B 1 kahi result 1 hi thena dia. Chai A ka 1 ka koi chenga khat pa ka 0 hi ngai. Yes. Mala. Khat pa okay 1 hi le chai A ka 0. So khat 0 hi ngai. Total okay, total has to be, in order that total has to be 1. Yalam ne hoche ta, okay. Chai A 0 koi, chai B has to be 1. Okay, velam ke panna pai phele. Okay, mole fraction of A, pure A, okay, decreases from 1 to 0, whereas mole fraction of B increases from 0 to 1. And when mole fraction of A is 1, okay, from Rao's law, okay, from Rao's law. What is Rao's law? P A is equal to P naught A chai A. Mole fraction of A is 1. So we have 1 there. This is 1. P naught A P A equal to P naught A. So finally what? P A equal to P naught A. Okay. Pure atmospheric, pure vapor pressure of A has become what? Partial vapor pressure of A. So somewhere here you will put, okay. Let's keep it. P naught A. Good. The same logic when, okay, chai B is equal to 1. So P naught B equal to P B equal to P naught B into chai B. Chai B is 1. So P naught B is equal to PB. So this place is also similar to P naught B, right?